like to demonstrate how an electrician would convert a fluorescent light fixture to the new SSL or LED lighting system. And one of the first steps will be to disconnect the power, which we'll do by simply unplugging this power supply, and exposing the bulbs by taking the diffuser off. And as you can see, these have the electronic ballast in it, and it has the T8 type bulbs, which are pretty energy efficient. But when we compare this to the new solid state lighting system, which we also refer to as LED, there's a tremendous amount of difference in the power that they consume and also the longevity of the bulb. So that makes it very beneficial to go ahead and do that. One of the things that the electrician has to do is disconnect this incoming power from the input to the ballast, or the part that was driving the fluorescent bulb. And they're going to have to take this power and connect it to the end sockets on one end of the fixture. And the changes that have just come about recently in this industry have required that the power come into one end of the light bulb or the other, and not both ends of the light bulb. So what we're going to do is take the hot and the neutral and connect it to the two pins on one end of the socket system. And that's what I'm doing right now, is connecting the neutral coming in to one side of each pin. And I'm going to take the other side of each pin down here on the end of the socket and connect it to the power coming in. So effectively, we've bypassed the ballast, and we could even at this point remove it from the fixture if we needed to, or we could just leave it in there. But the ballast incoming power is right here, and it's completely disconnected. So the ballast, the original ballast that was lighting those fluorescent bulbs, is not even in the scene. The main power is coming in and applying to one side of each pin on the hot side, and the neutral is coming in and applying to the other side of each pin. And the old bulb that I took out was actually drawing 48 watts for each bulb. And the new bulb that I'm going to put in is only drawing 10 watts per bulb. And when we use the formula that says the time that the fixture operates multiplied by the wattage of the fixture multiplied by the cost of the electricity per kilowatt hour, if we do that and divide that by 1,000, that comes out to the cost of running this fixture, how many dollars and cents it costs to run this fixture. We did some cost extensions and found out that this existing light fixture with the fluorescent bulbs in it would cost us approximately $6.30 a year to run. When we convert it over to these less energy consuming solid state lighting systems, we're going to have a total cost of $2.62 a year. So we've realized a savings there, but we've also got the ability to look at the cost of life of this fixture. As the old fixture was put together originally out of the box, this bulb was designed to last about 7,500 hours. And we did the cost extensions of the new solid state lighting, or the LED light bulb, is approximately 50,000 service hours. So we found out that this bulb would have to take about 7 bulbs. You'd have to be buying this bulb over and over and over again for the 50,000 hours, and it'd take about 7 sets of bulbs, and there's 2 bulbs in it, and they're about $10 a piece. So the cost of the solid state lighting is a lot higher, and its lifespan is so great that it actually averages out. And we ran the lifespan of these 50,000 hour bulbs out compared to the fluorescent bulbs, and we found out that the total cost of electricity and bulbs for this original fixture was going to be about $4,235 to run for 50,000 hours. When we convert this, we don't have to worry about buying another ballast, and that cost also was as if you didn't burn out the ballast, which that does happen in the fluorescent industry also. But if we convert it and these bulbs serve for 50,000 hours, we've, number one, saved electricity. Number two, haven't had to buy any more of those fluorescent bulbs and the downtime of changing the bulbs. But we found out that the total cost of this whole fixture over 50,000 hours operation time was $1,229. So we've actually saved $3,000 over the lifespan of this new system. One of the things that this new system allows us to do is to put different color ranges of bulbs in this fixture. And one of the things you'll see in this demonstration right here is a 6,000 Kelvin bulb and a 3,000 Kelvin bulb. And there is one in between that, which is 4,500 Kelvin, and that's referring to how bright the bulb is and how hot the light is. But this is kind of a demonstration of one extreme to the other. And when we put the diffuser on, you can kind of see that it's going to smooth it out a little bit and make it a little bit easier to understand. So today in this demonstration, I've demonstrated to you the cost savings of changing to a solid state lighting, which we also refer to as LED lighting system, the longevity and the overall savings of the cost of the life of the fixture, the less maintenance involved in that, and it's running cooler and it's a little bit nicer light fixture than the fluorescent is. There's less hazardous materials involved in it, but I've also demonstrated how an electrician would simply make the change by eliminating the ballast and wiring the power right into one end of the sockets. And it's something that demonstrates how an electrician would make this change, and it's going to be a big important part of our future in our industry. Thank you.